So today we're going to be talking about synthetic division. We've spent the last couple of days doing long division and dividing polynomials using long division. And it has a great name because it's called long because it does take a very long time to do. And so today I did want to talk about another option. I do want to start out by saying this is a cheat. It is not um, it's not what actual polynomial division is. It is a trick and an organizational tool that can help you to do the division quicker. However, when you get into pre-calc and the next level of mathematics, being able to do this division quickly is a huge help. And even in the rest of this math course, when we get into polynomial functions and actually having to find parts of polynomial and rational functions, being able to do this division quickly is amazing. So it is a skill I highly recommend that you pick up. So that's what we're going to be talking about today. So we're going to start with the steps. So our steps are, as you can see here, if you have a division problem, there's a couple of things about synthetic division that you do need to know. A couple of things that you need to know in order to use synthetic division. The first thing that you need to know is that synthetic division only works if you are dividing by a linear factor or a linear a binomial, a linear binomial. That's the divisor has to be a linear factor. If it's x squared, you cannot do synthetic division. If there's a coefficient in front of x, you can't do that synthetic division without some cheats. It has to be a linear factor because, again, this is not true polynomial division. It is a cheat, but it takes up a lot less space, a lot less paper, and a lot less time. So it is well worth learning how to do. However, it does not work all the time. That's why we have to use long division. It's the only one that works all of the time. So that's an important thing to note. You want to make sure that it is being divided by a linear factor. So to do synthetic division, the first thing we have to do is set up the synthetic division. We have to, when we did long division, we had to put it under the division bar and get everything set up the right way. Well, again, synthetic division is trying to streamline the process. It wants less things to write. So when we're doing synthetic division, we actually don't need to write all of the x's. All we're actually interested in are the coefficients, because the coefficients are the only thing that we actually do any arithmetic with. And so when we're doing synthetic division, we're just going to take the coefficients only. And we're not going to put the x's there. It is, however, important to note that when you are setting this up, all of the powers of x have to be present. So whatever your degree is, that highest exponent, you have to make sure that there is a place for every x beneath that. So with x to the third, you have to have x squared, x to the first, and the constant. Constant is technically x to the 0, because anything to the 0 power is just 1. So all of the powers of x have to be present. And just like with long division, if one of them is missing, you do have to use a placeholder. Now, unlike long division, where the placeholder does make things easier, but you can still technically do long division without it, if you don't use a placeholder in synthetic division, you will get the wrong answer. So it's not optional. If you are doing synthetic division, you have to use placeholders. So when we're setting up our division, we only want to put the coefficients, and then what we're dividing by, our divisor, we actually want to know, what is x equal to for this factor. So x minus f equals 0, then x is equal to f. It is always the opposite of this number. This is what we want to use for our synthetic division. And so I'm just going to sit this f out here outside, just like, the other division bar. But notice I just draw my division bar upside down. And I also leave myself a little bit of room here. You'll see why in just a second. So this is the setup of the synthetic division. We're going to take our all of our coefficients here, just the coefficients. And then we're going to take what is x equal to here for this factor. What is its root there? And this is how we set it up. Now, to get the synthetic division started, we're going to bring down the leading coefficient to the bottom row. So where we have all of the coefficients written up here, and we have that divisor, the opposite of it, written out here, the first step is to actually carry down this first leading coefficient, and it's just going to go down to the bottom. That's kind of what gets the ball rolling, so to speak. That's going to get us started. The next step is then to take f, the number we're dividing by out here, and multiply it by that first leading coefficient. So, whatever f times a is. And then I'm going to write it up here in the second column. And then what I'm going to do is I need to add, step 4 is to add this column together. So I'm going to take whatever this second coefficient was and what I got when I did f times a, and I'm going to add it, and that's going to be the number that's going to go right here. And then we're going to repeat until it's done. So then I'm going to keep taking f times this number, and then I'm going to add this, and then I'm going to take f times that number, and put it here, and then we're going to add this. And then when I get to this last row and there's no other row to go to, I can just stop adding. And so that is the pattern that we are going to follow to help us do synthetic division. What you'll notice is that I get to divide this whole polynomial, and this is the only space that I take up. It doesn't have as much of writing out polynomials as we do with the long division. So it does not actually take as long, and that's a good thing. So we're going to see what it looks like when you actually have some numbers to go into this problem. So let's look at our first example. So first thing that we want to do is that first step, which is to set up our synthetic division. We just need to set it up to do the division. So first we're going to take our little upside down box here, and I just need my coefficients. So I have 1x to the 4th. There are 0 x cubes. So I need to make sure I use a placeholder because there weren't any x cubes. I have a negative 6x squared because you don't want to forget signs matter. So we want to make sure that we're paying attention to whether it's a positive coefficient or a negative coefficient. And we don't need to write the x squared. We just want the number. All right. Now, x to the first power, there aren't any. So again, I'm going to need a placeholder. And then x to the 0, that constant, is negative 27. So I paid attention to my signs. I made sure I had my placeholders. I got that set up. Next, we want to know what our divisor is going to be out here. So we want to know where this is equal to 0. So that's going to give me x equals negative 2. So I'm going to have a negative 2 out here as my divisor. So there's step number 1, is just getting it set up. So again, coefficient of 1, missing x cubed, negative 6 in front of the x squared, missing an x, and negative 27 for the constant. So we have all of our powers. Step 2 is the one that wanted us to just carry down that leading coefficient. So that very first term, this one at the very front, we need to just drop it down and bring it down to the bottom row. That's going to be our very next step. And after we do that step, we get to step number 3, which was to multiply by that divisor, that number that we've got up front, from the term that we're dividing by. So I need to take negative 2 and multiply it by 1. And then we get to that next step, step 4, which was then to add the column. So 0 plus negative 2 is going to be negative 2. And then step 5 just told us to repeat this process. So we're going to repeat the process. So I'm going to say negative 2 times negative 2, which is positive 4. And when I add negative 6 and positive 4, I get negative 2. Negative 2 times negative 2 is positive 4. And when I add 0 to 4, I'm going to get 4. And then negative 2 times 4 is negative 8. And when I add negative 27 and negative 8, I get negative 35. And so this gives me numbers. Now the problem is when I look at that, I'm like, well, that's not a polynomial, that's a problem. And so what we have to remember is this again was a shortcut. It was trying to get us to just do the arithmetic we needed to with the numbers and not having to keep writing x to the fourth, x to the third, x squared, x to the fourth, x to the third, x squared, constantly writing all of those variables over and over again. So what we have to remember is that we took x to the fourth and we divided it by x. And so this quotient is always going to end up being 1 degree less than what we started with, because again, synthetic division only works if we actually are dividing by a linear factor. So it's always going to be x something. So it's always just going to be 1 less. So that means these are the coefficients for the quotient, and it's starting with x cubed. And then we just count down from there. X squared, x to the first power, x to the 0 power, that's our constant. And then what happens is this last number always ends up being our remainder. It'll always be our remainder. So if something actually divides it evenly, if it is a factor, then it's going to be 0. Your remainder would be 0. If you have a number in that last spot, that means that it doesn't divide it evenly and that it has a remainder. So then we just have to remember our options for writing our answers. We can write it with the fraction remainder. So we could say that the quotient is x cubed minus 2x squared minus 2x plus 4 plus negative 35 over x plus 2. Remember, when we write a fraction remainder, you just take whatever your remainder is and put it over the divisor. We also know that we can write it as a multiplication statement. So we could say that x cubed minus 2x squared minus 2x plus 4 times x plus 2 minus 35 is the multiplication statement that equals x to the fourth minus 6x squared minus 27. So we have our fraction remainder form, and we have our multiplication statement, depending on which one the problem has asked you to write your answer as. So notice that instead of having to use several lines of long division and having to do the repeat process at least 4 times, we actually only used 3 little lines of paper and got all of it and still got our answer with our fraction remainder. And so synthetic division goes a lot quicker. It's stuff I can do all in my head. I don't have a lot of distributing to keep up with. Notice that the only sign we have to keep up with is really making sure that we copy our signs down correctly and making sure that originally we do always take the opposite of this number. But once we've done that, it's really just a matter of multiplication and addition and all just arithmetic. And so it really does make that into a much simpler process. Now, I did mention that the big holdup with synthetic division is that it only works if you're dividing by a linear factor. It does not work if there's a coefficient in front of that linear factor. So the way we get around that is that we have to factor out that leading coefficient. So when I do that, I always end up with x minus f over g. And so that means that when I'm setting up, when I do this setup step for my synthetic division, these coefficients are all going to move over here just like they did last time. We're going to make sure we have placeholders and all of that kind of stuff. But instead of just having f out here, I'm actually going to have the fraction f over g. But our steps are going to all stay exactly the same. Now, after you've brought down your a, and then you've multiplied, and you've added, and you've multiplied, and you've added, and you've multiplied, and you added, the only thing that we still have to do that is different than when we didn't have a number up here is, since we did our synthetic division with just this fraction, we haven't actually divided by g yet. And so what that means is whatever we get for our answer, I am going to have to go through and I'm going to have to divide everything by G. So we're tricking the cheat. You know, synthetic division is a cheat. And now we're cheating the cheat to make sure that we can actually divide by any linear factor and not just the linear factors where the leading coefficient is 1. And so we do need to add at the beginning that instead of just being the opposite of this number, it has to be the opposite divided by G. And then when we get to the end, we have to make sure that we take our quotient and divide everything by G. So let's look at an example. All right, so step number 1 is still going to be to set up. So I'm going to come over here and get my box going. I've got a 6x to the 4th. I've got a negative 13x cubed. I've got a negative 2x squared, a negative 8x, and a negative 3. So I didn't need any placeholders. We had all of the powers. But here I notice there's a 3 in front of the x. So that means that I want to figure out where this is equal to 0. So it is going to be negative 1, and then I have to divide by the 3. So x is equal to negative 1/3. So what I'm going to put out here is negative 1/3. What we've really done is we've factored the 3 out, and we have 3 times x plus 1/3, because synthetic division really can only divide if this has a coefficient of 1. So we have factored out the 3 and figured out what that is. Now we can go on to the rest of our steps. And if you recall, our steps are step 2 to carry down, get it started, get that first term brought down. I'm going to carry down a 6. Step 3 is to multiply by that divisor. So I'm going to do negative 1/3 times 6. Negative 1/3 times 6 is negative 2. And then step 4 is to add that next column. So negative 13 plus negative 2 is negative 15. And now all I want to do is repeat. So I'm going to do negative 1/3 times negative 15. Negative times negative is positive, and 1/3 times 15 is 5. So I'm going to add negative 2 and 5 and get 3. Negative 1/3 times 3 is negative 1. Negative 8 plus negative 1 is negative 9. And negative 1/3 times negative 9 is going to be positive 3. And negative 3 plus positive 3 is actually equal to 0. So I kept multiplying, adding, and repeating until I ran out of things to multiply, add, and repeat. I got to the end, and I actually see that my remainder is 0. So that means that this was actually a factor of that. And now I need to remember that new step 6. And step 6 says to make sure that I divide by G. What was that number that we factored out at the very beginning? It hasn't actually been divided yet. So I need to make sure that I go through and I divide everything, including the remainder, even though in this case the remainder was 0. That doesn't do much, but we have to divide everything by 3. So that means when I actually write my final answer, it's going to be not 3. It's going to be 2, negative 5, 1, negative 3, and 0. So it will be 2, and again, we're always 1 power less. So if we started with x to the 4th, our quotient will be x to the 3rd. 2x to the 3rd minus 5x squared plus 1x minus 3, and it had no remainder. So this would be our quotient with a fraction remainder. If we were doing a multiplication statement, we would say 2x cubed minus 5x squared plus 1x minus 3 times 3x plus 1. And also, that is how you can check your answer. You can always multiply this back out and make sure that it does give you the polynomial that you started with.